that we have been done and the results that we have. So starting with what is Pledger. Pledger is an H2020 EU funded project that has already ended. So our latest results are already there. What we did is to progress beyond the state of the art on cloud and edge technologies to build something that can be used in many different types of industries. We also make it adaptable to different environments, so it can be used by many people in many different situations without changing the underlying technology, and we try to secure everything. So what you will see, at least in the first part of this morning, is our main results that are the Pledger core platform, the features that it has, the different functionalities that have been implemented, and how everything works together. We position ourselves with different innovations that some of them are used within the use cases and some of them can be also used by external stakeholders. And we try to make the architecture very modular and interoperable, so you only use what you need in case you have any issue. So for the agenda that you have, we will have two main blocks. The first one is the first part of the morning that relates to what is the Pledger platform, the functionalities, how to use it, what do you have to see. And on the second part is the use cases and the main benefits that using Pledger brought to them. At the end of each block, we will have a small session where you can make all the questions that you have. So in case you have any during the presentations, please write it down in the chat. So we will take notes and make them at the end of each of the blocks. We also share a survey with you, so you can provide us some feedback about not only the presentations, but also the different things that Pledger has been implementing. If you have the feeling that I have many interests, or if you think that something else is missing, or any idea that you have for the future that can be implemented. So if you want to know more about the project, here you have all the links to our social media channels. You can also visit the website. You will have all the documentation and everything there. Or if you prefer a direct contact, you can write to me or to our general information mailing list. So that's all from my side. As I said before, thank you all, and I hope you enjoy the different presentations.
Thank you very much, Lara, for this introduction to the project. So let's start with a description of the overall architecture and the overview of the main subsystems with ICCS.
Thank you very much, Olga. Good morning, everyone, from my side too. I'm Orpheos Voutiras. I'm a research engineer at the Institute of Communications and Computer Systems of the National Technical University of Athens. And as Olga already mentioned, I will be presenting to you the overall technical view of the Pledger platform, just for you to get an introduction, mainly to what we would like to refer to as the technical challenges and non-technical ones, we could say, and the actual solution we provide. About the challenges per se, we have in our mind mainly two types of end users, we could say. One is that of the software as a service providers, and the other one is that of the infrastructure as a service provider. So on the one hand, we have people that want to develop and deploy their own applications or software on specific resources, edge resources or cloud resources. And on the other one, on the other side, we have the actual providers of those resources. So moving on, each one of these two groups of end users have their own needs, pains, problems, and gains they want to have. On the one hand, the SaaS, the software as a service providers, want to understand better the computational needs of the applications, so that they can know on what infrastructures they can run, and so on and so forth. They want to investigate the quality of service of specific services on that matter with well understandable metrics. They want to have balance between the cost of the infrastructures they use and the performance of the applications, being secured by that infrastructure, and of course they want to monitor specific service level agreements. On the other hand, the infrastructure as a service providers want to handle the dynamicity of workloads. They want to adhere to the service level agreements they have agreed upon with the SaaS providers, and they want to ensure stability and performance and enhance the feeling of trust towards the consumer of the resources. In that sense, Pledger tries to cover both of these sides and both of the views, mainly through several, let's say, questions regarding the usage of such resources. For example, a software as a service provider may have as a main issue to tackle the deployment either on the edge or on the cloud. And this is a decision they may have to take at the early stages of the deployment. Similarly, after resolving this question, they may want to know on which edge node, which specific provider they should trust, for example, or which resources are the necessary ones and not too much for them to handle. On the other hand, they may have the same question for specific cloud services. And finally, in case something goes wrong or we need some kind of migration, either to move computational power to the cloud or to do the opposite in order to decrease latency, then we have the question of migration to or from the edge to the cloud. The application scenarios we have specifically in Pledger are three, without this meaning that the core system that we have developed cannot be applied to many other applications, and I will discuss about this point later on. The first use case you will also have the chance to study today and observe is related to augmented or virtual and mixed reality applications on the edge. The other one is about smart mobility, especially focusing on edge infrastructure used to enhance the safety of vulnerable road users by specific sensors and also notifiers. And finally, we have a use case related to industrial Internet of Things, focusing on manufacturing machinery and the corresponding data that needs to be mined on the edge. About specific requirements and data, just to give you an overall technical view of these scenarios, but can be extended, of course, to many other similar or not so similar use cases. For the mixed reality scenario, we are working with render views of 3D scenes. We want to take under consideration spatial data from augmented reality devices, and everything has, not everything, a lot of things have to run on GPU-based edge nodes in this case for processing streaming. In some cases, we may need some outsourcing of the rendering capabilities. So this is related to the migration we mentioned. And all of this has to be scalable depending also on the usage of the resources. For the smart mobility scenario, we care about sensors that give us notifications about the position and direction of vulnerable road users and other vehicles or public transportation ones, such as a tram. And the infrastructure being used is the specific sensors and the machinery and notifiers for the alerts and so on and so forth. And finally, for the industrial IoT, we care about operating states, pneumatic data, the axis positioning, for example, of the machinery. And in this case, we have a convolution of edge and cloud services, we could say, where we have to secure specific benchmarking capabilities. Now about the solution, we have many catchphrases we could say for the project, but specifically for this technical part, in the dilemma of edge and cloud, Pledger tries to couple the benefits of both worlds through the usage of the appropriate source and node or cloud at the appropriate time. This, of course, needs a lot of, let's say, planning for that. Overall, the technical pipeline we followed is the analysis of the use cases we mentioned, extraction of requirements that are generic enough to be adapted also to other scenarios. Then we had the extraction of the Pledger-specific architecture, the development and integration of the tools of Pledger, the demonstration of them, and in parallel monitoring and evaluation activity. Today, of course, we are here today and we are more than happy to show you our final results regarding the demonstrators, so you will have a chance to check many of the features and the capabilities of the tools that Pledger can provide for scenarios such as the one we described before. About the overall methodology, as I said, we started from user stories and user requirements. Here you will see that a lot of them are mapped to the specific use cases, but can be generic enough to also be applied for other scenarios. And similarly, we followed a very, let's say, meticulous way to extract and manage the requirements, and after that to define an architecture that will aggregate all the capabilities and features that ensure that the requirements that have been mentioned can actually be covered. About the behavioral view of our core system, we take care of specific interactions of our system with both users, both the software as a service providers and the infrastructure ones. Indicatively, here you can see some generic actions that such users can take through Pledger, and as you can see, there is no restriction for such tools to be used for many other edge-specific scenarios. For example, we may have here the provider wanting to deploy a specific application component to get information about their application instances, to control the application instances. And similarly, for the first part, you will see that they will want to view available resources and infrastructures on which they can deploy their applications and get also recommendations about these resources. Similarly, if we follow the path of decision-making for this user, at some point they may want to choose to migrate their application or parts of it and parts of such components to other infrastructure. So Pledger takes exactly this role and facilitates this type of decision-making. Similarly, we have other scenarios where we assist the SaaS or IaaS providers in parallel or in distinct ways. Let's say for the infrastructure as a service providers, of course, we provide monitoring and self-assessment tools. Again, for infrastructure as a service providers and SaaS interaction, we give the option to SaaS providers to evaluate, let's say, the offered infrastructure. And similarly, we have, of course, the interaction between these two users through their agreements, the service level agreements that they have signed between them. Now, getting more specific about the structural view of the core component of the core system, Pledger core system, in other words, the functional components of Pledger, you will get many more details in the next sessions through demonstrations also. So don't get overwhelmed by the many black boxes you may see in the beginning. Everything will become clearer later on. But in general, we have three different layers, let's say, in our architecture. One is based on management subsystems, and there we have some of the more core functionalities being offered for the interaction of both user types with our system. Then we have an evaluation subsystem layer, which is related to the evaluation of the resources and the applications and the corresponding monitoring mechanisms. And finally, we have a support subsystem layer, as we call it, which offers other capabilities such as integration capabilities, security, and blockchain offerings. To get more specific, here you can see more core components and some indicative examples, which you will be able to check later on too. For example, on the orchestration subsystem, we offer orchestration services that can lead later on, depending on the needs of the users and their decisions, to the deployment or redeployment of components or entire applications, scaling, migration actions, and of course the corresponding monitoring activities. Similarly, there may be need for configuration of the infrastructure and the applications, and of course the corresponding testing of such resources and applications through benchmarking schemes, and the monitoring of the specific SLA, service level agreements between them, with many, many other components offering extra features. Now, Pledger, of course, is not a monolithic core system as it is. As Lara mentioned at the introduction of the project, the scope is for Pledger to be modular and to be able to be integrated with many, many other scenarios and use cases. So you will see today several subsystems or components that you may want actually to isolate and adapt for your scenarios, so that's completely okay. But here, for example, you can see how different parts of Pledger could be used in the three identified use cases we will present today, even though all these three scenarios have entirely different use case specific, we could say, subsystems, with the smart mobility scenario being related to infrastructure at the city of Barcelona, with the industrial IoT scenario being focused on machinery in an industrial environment, and so on and so forth. Finally, about what I just presented, these are some early results of our project related to the use cases description, the requirements analysis, and the overall architecture of Pledger, introducing the corresponding paradigm, coupling edge and cloud. We would be more than happy to see you exploiting these results, even the early ones, beyond the technical components that we'll show you. So here are some of our first deliverables. In the next sessions, you will also have the chance to check other technical capabilities of Pledger per se. So thank you very much for your attention, and that was it from my side.
Thank you, Orfez, for this introduction. So I think that it is necessary in order to give everyone the proper context in terms of the demos that are going to be shown today. And on that note, let's go on to the next presentation on exploitation and business planning with ATOS.
Thank you, Olga. Let me share again my screen. So what I'm going to present now is a non-so-technical perspective about the Pledger solution and how you can use it. So as Orfea said, we have this Pledger core platform that we must reduce and simplify it to a single sentence. Is that is modular, is mainly open source, and is something that you can use for deployment and execution of service applications without having the specific knowledge on the technical side. So problems that we solve, we avoid the vendor locking because we can work with different infrastructure providers. There are some issues also sometimes with the integration of different technologies. Pledger is completely integrated. It is using a communication bus. So you just need to send the message if you want to make something new. We are working with different environments in the continuum from the edge up to the cloud and vice versa. We automate the orchestration on these environments. We decide where to scale horizontally or vertically or both to select the better deployment scheme for each of the applications. We also try to improve the quality of service for the user, but also the quality of experience of the final application user. And everything of this is completely secure. So the evolution of Pledger was as in many other projects, we start with the initial idea, we design the architecture, it was developed, it was integrated, then we test it to see how it works, and we integrate it with the different use cases. So we also collect some feedback from them to see if we need to refine something, if we need to add any additional functionality, validate everything, And finally, we have this Pledger Core platform. Once we have it validated, we have it working, we have it fully functional, and it's also available on GitHub if you want to download the code. We develop our final offering. So the final offering is mainly in 3 different, let's say, blocks. One is the software. We have 7 open source components that are available in GitLab. It have the needed documentation for downloading, installing, to use it. You have also some videos about how everything is working on their own or how everything is working integrated. But we also have 2 other components that are not open source. For this, you also have some information, but you cannot access to the code. But at the same time, to improve the quality of experience of the Pledger users, we also provide some information with demos about how everything can be integrated, about how everything can work in the use cases. We also develop some toolkits for the service provider, for the infrastructure provider, for those ones who need an additional layer of security, or if you want to integrate blockchain technologies within the whole platform. And we also have developed this handbook that is a how-to guide, and you will know more about it later, about how to use everything in a simplified manner. So at the end of the day, what we provide security functionalities. So we can prevent attacks and protect microtransactions that are happening within the platform. We ensure the quality of service and try also to improve it, monitoring SLAs and negotiating the smart contracts between the infrastructure provider and the service provider. So all transactions, as I said before, are protected. We are using machine learning algorithms, but at the same time, these machine learning algorithms have more than a 95% of accuracy in terms of benchmarking and profiling. So it's also a reliable system. Additionally, we have network slicing with compute and radio chunks, so you can get the maximum benefits from each device. So it's not a matter only of orchestrating deployment, but also you can create these slices. And we provide the best deployment schemes for horizontal or vertical scaling for each of the applications. In this case, we are also taking into account energy efficiency considerations. So our business model indeed is in 3 pillars, as it happens with many of the open source code. So for free, of course, you can download and modify the source code. You have the documentation, you have the basic support that you can have on GitLab, just making questions on the forum. You can have a pull and push request. For those components that are not open source, indeed, you will have to pay for them because they are not available. If you want some dedicated support, even for the open source code, this is something to be paid. The dedicated support means the whole day, something very specific for your business, or if you want that someone installs it for you and integrate it with what you have, or even to maintain not the source code, but to maintain the applications that you are deploying. And finally, we have the premium one, where you have additional features, something very specific that you will need to integrate it with your existing systems, or in case you want to have a license for apply to it and you want to forget about I need to download, I need to install, but I want you to do everything for me. This is something that is part of our fee. And I put here the final video so you can see it.
Yeah.
Lara, sorry, I think you haven't shared the sound for the video. You haven't shared the sound for the video. It's the option given when you have to share screen.
Oh my God.
If you go to the share icon, at the very top, share content, next to it says include computer sound.
You mean here? Oh,
Stop it and try again. You will see at the top a toggle to include computer sound.
Okay, now yes.
Yeah.
Oh, thank you, Orpheus. So make it bigger again.
Perfect.
The digital single market strategy set the basis for accessing the online world to individual and businesses. The rise of new technologies and paradigms, from IoT to 5G, supports the digitalization of current business infrastructures, allowing organizations to improve their processes and develop new businesses. And this has highlighted gaps in the current approaches. Pledger takes advantage of this situation by exploiting the advantages of edge and cloud paradigms, solving latency problems faced in the cloud by just moving executions to the edge, while migrating big data analytics to the cloud to solve the lack of capacity at the edge. Pledger's modular platform supports digital transformation of European industry, providing means for intelligent and automated workload deployment and orchestration in multi-edge environments, from the edge up to the cloud, or vice versa. Here we add the step-by-step app deployment. User logs into the system. User registers his/her app. User selects the provider infrastructure, with the support of Trust and Reputation Engine. User specifies quality of service in the SLA template. Smart contract is created. User starts the app. User interaction ends and Pledger starts the automated process. Decision support system scales decides the best deployment scheme and notifies to Orchestrator. Orchestrator deploys and starts the app. If needed, a slice is created. Monitoring engine continuously monitors resources and SLAs. Decision support system scales or offloads the app to optimize resource consumption and reduce SLA violations. Smart contract is updated. Monetary penalty if something goes wrong. Security is guaranteed along the process. Simplify edge, cloud service management using Pledger.
As you have seen, you don't need to have a very technical specific level of detail about how to do this orchestration or deployment of applications, because you have this platform that is doing it for you. So you can concentrate on develop the best application that you need. And this is everything from my side. So.
Thank you, Lara, for introducing the business aspects of the proposed solution of Pledger. So let's dive into the technical stuff and all the detail and the components that were developed within the project. So let's start with the performance, quality of service and orchestration mechanisms by ATOS.
Hello, can you hear me?
Yes, we can hear you.
Okay. Hi, I'm Roy Sucasa from ATOS. I will present now the Pledger performance, quality of service, and orchestration mechanisms. And the idea of this presentation is to show the work done in the part related to performance, quality of service, and orchestration mechanisms of the Pledger framework that are part of the Pledger core platform. The main object.
You are breaking up. You are breaking up, and we cannot hear you very well. Can you switch mics? Hello. We cannot hear you very well. You're breaking up. Should we?
Can you hear me now?
Yes, perfect.
Much better.
Thank you. Yes, much better.
Okay. Sorry. Well, the idea of this presentation is to show the work done in the part related to performance, quality of service, and orchestration mechanisms of the Pledger framework. And the main objectives are the following. First, to do the performance measurement, benchmarking, and classification of the edge nodes and cloud infrastructures. Then the implementation of the edge and cloud computing orchestration tools. Also, the SLA management and negotiation tools for the service provisioning on Edge and Cloud. And finally, the creation and management of the metrics that are used to perform the necessary quality of service and quality of experience. The major achievements are the following: the implementation of a fully integrated set of tools and services to implement performance measurement and classification, quality of service and SLA assessment, and orchestration mechanism. All of them are part of the Pledger core system tools. And another achievement is the demonstration of the benefits of these tools in the 3 use case demo scenarios and also in the demo videos that are available in YouTube. The following diagram shows where this set of tools and services are located in the Pledger framework. Part of them are in the management subsystem and the others are in the evaluation subsystems. Now I will enter a bit more in detail in the different parts of the pledged performance, quality of service, and orchestration mechanisms. First, the part about performance and classification. One of the objectives of Pledger is to propose an approach to measure the performance of edge and cloud infrastructures in a reliable, impartial, and comparable way. It is based on benchmarking, in concrete on the execution of small workloads to measure the response of the system. It allows to simulate and get the performance of different application types. It does the computation of high-level performance indicators and allow the analysis of historical data. And the resulting information is used to provide recommendations on the best nodes or infrastructures to run the applications. All these functionalities have been implemented by the benchmarking suite application. This tool, the benchmarking suite, automates the benchmarking process by allowing to easily define workloads, infrastructures, and schedule execution of tests in all the Pledger infrastructures. It also does the automatic execution of tests, including the provisioning and the provisioning of the provider's resources. And it also does the automatic extraction and storage of the test results. The benchmarking suite application offers advances in visualization tools with filtering and aggregation result options. And finally, the results and reports produced by this tool support other Pledger components to take deployment decisions. Finally, we can see in the diagram this tool as part of the Pledger evaluation subsystem. We have 2 demo videos about this tool in YouTube in the following links. And now the part about edge and cloud orchestration tools. The objectives of the edge and cloud orchestration tools part are the following: to provide a good usability with REST-based interfaces and graphical support for other Pledger components, to provide an improved application lifecycle management that supports the updating of already deployed software components, and finally, to predict the dynamics of edge and cloud computation based on the quality of service and quality of experience requirements. These objectives are covered by the following Pledger components or applications: the SOE and run controller, the application profiler, the monitoring engine, and the edge and cloud orchestrator. The application profiler offers a REST API for benchmarking and application profiling. It performs the analysis of the resource usage and needs of the applications, and it can also profile applications in various workloads in order to better predict the fluctuating resource needs of them. The SOE and run controller tools leverage the use of OSM menu to support the lifecycle of applications under specific network slices. It provides a dedicated isolated compute network and radio resource according to specific quality of service and quality of experience requirements of applications. And it also offers REST-based interfaces to perform all these tasks. The Edge to Cloud orchestration tool allows the deployment and management of applications in Edge and Cloud. It exposes a REST API and also an event-driven interface with Kafka to do all these tasks. And it enables the orchestration in edge and cloud, including the runtime adaptation decisions taken by the pledger system. Finally, the monitoring engine is the tool responsible for getting the metrics from applications and infrastructures by connecting to Prometheus or other tools. And it also exposes a REST API for Prometheus jobs and other pledger components. All these tools are part of the pledger management subsystems, in concrete the orchestration subsystem and the configuration subsystem. The application profiler is one of the components of the configuration part, and the other components are part of the orchestration subsystem. We have at least 5 demo videos in YouTube that include all these tools described before. And finally, the quality of service and SLA assessment and negotiation tools. The quality of service and SLA assessment and negotiation tools are responsible for the quality of service assessment entity, and it's linked to the pledger components that make use of this evaluation. It provides and supports an extended list of metrics to be used for the evaluation of different aspects of the service running in the pledger system. It also offers visualization aspects for the end users. And finally, it offers an extended queries in order to extract more concentrated information with relation to the quality of service aspects gathered from the individual experiments of the users. These functionalities and objectives are covered by the SLA Elite application. The SLA Elite application is part of the evaluation subsystem, in concrete the SLA subsystem. And there are 2 demo videos in YouTube that show this application. And that's all. Thank you.
Okay, many thanks, Roy. And I guess we are right on time. So let's move forward to the next part of the technical presentations in terms of the trust, smart contracts, and decision support mechanisms.
Yes, hello everyone. Just let me share my screen. Wow. 1 second, I'm having a problem with this. Okay. Perfect. I should be here. So, okay. Sorry for the delay, and let's start. Can you see my screen?
Yes.
Okay, perfect.
Just if you could
yeah, one
do it full
second.
screen.
Oh, okay, perfect. So here we're discussing these 3 additional features, which are security and trust, the blockchain, and the DSS. We will see a bit of everything, and then with the main leaders that we worked with these features, and then back to me with the DSS. So from now, I would, again, switch to Olga for the trust, security, and privacy, and then to Nikos, and then back to me for the DSS. Okay.
Okay, thank you, Francesco, for the introduction. Can everyone see my screen?
Yes.
Okay, so let's start with some basic information about the security subsystem that is part of Pledger. So at this time, we started to perform a very detailed threat analysis within the project. So the overall assets that were deployed and the configurations that were made in order to secure and harden our infrastructure were performed not just on the basis of the description of action, but also in terms of the threat analysis that we perform, specifically for the infrastructure and the components of Pledger. So this had 3 different layers. So at the bottom layer, a set of hardening measures that we applied to our own infrastructure. Some examples of these are the authorization and authentication mechanisms of the big data infrastructure, the secured private container registry for the CI/CD system, and a variety of configurations and additions to the Kubernetes cluster. At the second layer, we developed specific security assets for the project, and that started with the basic security defenses that were virtualized, so we could launch a variety of different instances in slices or in the compute hosts of the clients. That included intrusion detection, it included a honeypot and the deep learning experimental algorithms. In terms of the Kubernetes cluster, we will be showing a bit later that we applied some security benchmarks and a variety of network security policies. And in terms of some of the other major assets, there is a specific subsystem on trust and reputation that allows us to have a ranked list of trusted infrastructure providers. And some additional developments in order to better visualize and gather the variety of security information and threat information were built on top of this in order to better understand the intelligence that came our way. So let's start with some of our examples. One of these examples is a virtualized intrusion detection system, in which case we set up a variety of instances to collect threat data. And one of these instances was provided in detection mode to detect all the different threats on our infrastructure. And the one was defined as a honeypot in order to gather a lot of threat information on infrastructure that was basically sacrificial. So that allows us to review a lot of different real-time and real threats on our network, and also provided a basis for the threat analysis that we perform later on. So the positive aspects of this is that whereas the customers can enter their own specific instance and review the threats on their own infrastructure provider can have a bird's eye view of all the threats, of anonymized threats on their infrastructure, and have a real-time idea of what happens across their infrastructure. So we aggregate this data through our big data subsystem called Stream Handler, which will be... Sorry? Can you hear me?
Yes, Olga.
Oh, yeah.
Yes.
Okay, so these data are aggregated through the big data infrastructure we are deploying in the project and visualized through an ELK stack. So next, this is actually a day in the life of the honeypot instance, in which for a specific period of 1 week, we gathered almost 150K logs that we're gathering more than 1,000 threats, real threats that we saw on our honeypot, which ended up in 66 warnings and 11 critical warnings to the infrastructure provider. So some examples of the threats that we saw was mostly traffic from bad reputation IPs and very constant stream of denial of service attacks, mostly based on the NTP protocol. Obviously, these threats were cut off from our firewall after the threat analysis part was done. None of this malicious traffic would enter our security perimeter. So in terms of the trust and reputation subsystem, this was a very significant development within the project that allowed potential service consumers to select a service provider that is appropriate for them. It works very similarly to the recommender that was presented earlier, but in this scenario, extra trust information were added and published to the potential consumer. So at the end of the day, the consumer could select an infrastructure provider from a ranked list of top providers and review the reputation indices that can be used as an extra source of information to make their final selection. Another example of the trust and trust and security components in this subsystem was the CVE-CIS data aggregator that allows us to have a better understanding of the security rating of an infrastructure according to an official consensus-driven security guideline produced by CIS. So basically, service providers could access a dedicated UI that allowed them to check the security rating of each infrastructure. So at the end of the day, they were able to review a report of security checks that were passed or failed on a specific infrastructure. So you can see an example right here with a few security checks that were passed or provided a warning. So this is very valuable both for the clients and also for the infrastructure providers because these reports allow them to perform corrective actions on their own infrastructure. So a variety of demos are also available on YouTube, and we will share these links also on the chat because there are a number of technical demos that are available from Pledger. More than 30 technical demos are available. So we will be sharing a lot of these links with you during this meeting. Thank you. I believe we can go on to the next.
Yes, let me share my screen.
Are we ready to move on? We can move on to the next and circle back if that is necessary.
Olga, I was going to say, Nikos, if you are experiencing the same demo issue like me, if you want, I can share the slides for you and you can use it if you want, or we can move on with the next one as you prefer. But maybe this is not the problem because I see Nikos is not answering, so maybe it's out. So, okay, if you want, I can go on with the DSS. So let me just share my screen. Okay. So, okay, let's jump to the. Perfect. Can you see my screen?
Yes, Francesco.
Okay,
Yes.
thank you. Yeah, let me just switch on the camera. Perfect. So, okay, so back again with the DSS. Let me say this is a very interesting component, I would say, also because it's been designed and developed specifically for Pledger. And the main idea is to define and support optimal decisions for the scaling and the offloading that happens in order to achieve the desired QoS. So here you will see lots of interactions with the other components coming from Pledger, like the config service for, of course, everything related to the configuration, but also for the preferences necessary that are expressed by the service provider in order to select some infrastructure over others for many different reasons. Also, the integration, of course, with the monitoring engine for all the features and metrics that are monitored every time for checking the different QoS, and of course the integration with the SLA manager that sends violation but also warnings so that we can act and trying to anticipate any issues. Of course, there is also the integration with the benchmarking, the app provider that, as we will see in a moment, will be used in order to choose the best node that fits the needs for every application. And of course, the interaction with the orchestrator, which is actuating the decision. So you will see this in such a schema here, where the DSS is the, let's say, the central component in this workflow, with all these source of information, and then the orchestrator that is applying the decision over the cloud and the edge infrastructure. And but just trying to focus more on the DSS, we will. It's important to highlight is that the scenario that we explore is with private, scarce, and diverse edge resources. These are three very important things, because in the end, what we will try to do is to try to use the edge resources as much as possible. And we know that it's scarce and maybe it's very different. So we will span from maybe some high-level computer to small boards, for example. And in the end, what happens is that the DSS takes into account the different preferences from the service provider and creates some rankings. And then within these rankings, it applies some automation. So it's not just referencing to these preferences, but it also includes additional algorithms that have been designed for Pledger and also published in scientific publications. So in the end, what happens is that it creates some resource allocation models, adjusts the different thresholds in order to see when it's more important to offload or maybe to scale, and then does the offloading on the scale accordingly. In the end, we have different optimization algorithms, and try to summarize them a bit here. But basically, there is a bit of combination between trying to optimize the resource and latency, maybe just do some quick automation, like scaling and offloading in case something happens. Then we combine the same scenarios, trying to include also far edge nodes, and also in the end, the energy consideration that was mentioned before. And last but not least, the ability to use webhooks in order to, for example, customize or do some custom optimization in case it's needed. So we are trying to be open to everything, let's say. Here it's a very dense table that summarizes a bit the very different scenarios that we include, and for each of them, in the end, we have different algorithms. I mean, here is of course just a way to say, okay, we have lots of them, but the warm invite to you is to come and go to the public repository here, where you will find lots of detailed documentation, and also a way to replicate everything that has been developed, because we try to have to provide a test environment which would be easy to use for all the developers in order to engage them. And yes, so just a couple of additional slides. Yes, as I said, all the documentation is available on GitHub, but also lots of videos on YouTube. And yes, in order to, another nice point that you might be interested in is that to facilitate the adoption of system integration, we moved to using two different directions. So at first, we have this component that can be used as a standalone component that does smart orchestration and optimization, doing direct API calls to Kubernetes and the other, let's say, open source services that are used for the DSS. So this, let's say, allows you to use these components as it is as a smart orchestrator on multiple clusters in Kubernetes. But of course, the major features that you can get from this DSS comes when you work with this component combined with the other core Pledger services, where you can, of course, leverage on the benchmarking and the app profiler and the other things that brings everything to you in a much more complex scenario. Everything, anyway, is being documented, and as I said, with the Kubernetes in Docker, we provide all the instructions in order to allow you to test all these different optimization and maybe reuse it later on if you are, of course, interested. So just to summarize a bit of innovations that you might be interested in, the idea in the end is to have a smart auto-scaling, trying to reuse the same QoS model that comes from Kubernetes, but applied to different infrastructures. Because let's just remember that thanks to the orchestrator, we can basically manage any infrastructure that we want. So we are basically applying the same model, but to different infrastructures. Then, of course, there is this combination of benchmarks and a profiler that allows you to know which is the most performant node for a specific application, which is used during the DSS decision process. Then there is the support to hardware variety. And I mean, this is very simple, but effective in a way, because here what we are going to do is leverage on the variety that we have on edge, where, as I said, devices could be very different. And with this feature, we basically let the service provider know about what is available. And so that in the end, thanks to this combination here, we will, the DSS is able to do some smarter auto-scaling. So being aware of the actual capability of the hardware that is behind. And then, as I said, there is the support to the multi-tier infrastructure with the Cloud Edge and Far Edge. And again, the optimization doing with the latency resources, but also some energy consideration supported by IEEE scientific publications. And just to name the optimization algorithm used is based on Lagrangian optimization. This is in collaboration with I2CAT. So this, I think, is mostly all. I recommend you to, again, check the public repos for more information and lots of YouTube videos. And we will see you in a moment with the integration demo, where you will see all these components working together with the basic scenarios. So that's mostly all for the DSS, and I would like to pass the floor to Nikos if he's there, or if he's having still troubles with the slides, I can move it for him. So that's it for now. Nikos, are you there? Can you hear me?
Francesco, he's in the list of attendees, but he's muted.
Oh, I see. Okay.
Can you hear me? I think you can see my screen also.
Perfect. Welcome, Nikos.
Let's continue with the blockchain subsystem and what it has been delivered through the project these past 3 years. The blockchain subsystem consists of namely the DLT, the SLAs bridge, the use case, dApps, which is the decentralized applications, and trusted access. Let's see each component, how and what is actually, And let's just keep in mind that we have the blockchain network that hosts the dedicated components and their functionalities. So for the DLT, which is actually the blockchain network that is developed in Pledger, and it is an orchestrated network to trusted nodes. It supports private transactions, and it actually the deployments of the features are on the network of the blockchain. Here we can see actually a screen from the explorer of the network that we see the different transactions and smart contracts that are being submitted. So the SLAS bridge, what is the major innovation from this site in Pledger is actually the possibility to contribute the SLA contractual terms to some form of a blockchain smart contract that is deployed on a decentralized world. And what we are actually configuring through this module, this bridge, is that we can have the different SLAs that can be that are developed in Pledger and defined along with the monitoring of their violations. SLAS bridge is also able to handle the violations of each SLA and trigger the corresponding refund mechanisms as it is submitted on the ledger. For the use case, distributed applications, what Pledger offers here is actually a storage mechanism of sensitive information, and on top of this, in dedicated privacy features. Different level of data actually is delivered, and what the users can do with the dedicated applications that are deployed on the blockchain is that they can actually search the data in a secure way and perform authorized queries against the data. And on this screen, actually, we see how we have, as we see also later, the way that we have this kind of queries through the end user and how it is able to authorize and interact with the chain. As far as the trusted access that we have been delivering the past year of the project, first of all, the Pledger wallet is the way that users are able to, that end users are able also to interact with the data that is stored on the chain, and it follows the wallet principles of major wallets at this moment that are used for the blockchain networks, both for public or permissioned ones. On the screen, we see how we can log in into the wallet. The asymmetric cryptography is used by the users. This means that they just put their credentials and they can log in. And on top of that, more functionalities that are offered here actually is how the users can see data according to the role that they have and the dedicated privacy private environment that is offered to them. And this means that, for example, here, as we see in the latest three images, we have the different names of the three users. Imagine that they can log in and they can see their data and only their data. And this means that they're able to access data inside the blockchain, but they're not able to access data of another user. And this is the privacy feature that we have offering through Pledger Wallet and have developed during the course of the project. Here we have our latest demonstrations already on YouTube, and they're explaining all the process that we saw from start to end. And feel free to check them, of course. And I think this would be the conclusion for the blockchain subsystem. Thank you very much.
Okay, thank you, Nikos. I have already shared these links on the chat box. And overall, more than 30 technical demos have been produced for Pledger. They are all available on our YouTube page. Obviously, today we don't have time to review every single one of them, but we will be showing two specific core demos that are showing a few integrated capabilities. So I am also sharing our YouTube account on the chat box in case you want to review the demos that are representative of all the technical innovations that were performed in every component that was developed during Pledger. So with that, let's start with our two integrated demos from engineering and INNOV.
Thank you, Olga. Let me share again my screen. Okay, maybe this time I need to share the entire screen so that we can switch with the demo on YouTube. Okay, so 1 second. This will take around 10 minutes, no more than that. So yeah, as Olga mentioned, this is the first demo. This is most focused on the integration within the different components. So you will see a bit of interaction between yeah, many of the Pledger core components, some with user interface, some with the API interfaces, let's say. But yeah, the main idea, if you want to follow, I mean, at some point I will switch with to this demo on YouTube. If you want to follow on your own, you please feel free to go on. Let me, okay, iconize this. And yeah, as also Lara mentioned, we are preparing this project handbook that will end up on GitHub at some point, where you will see the main steps that are mentioned. In general, let me say, you will see the access to the system with the configuration of the QoS, basic one, the actual deployment coming, and a violation that will, according to the configuration and the preferences from the service provider, that will bring an application from the edge to the cloud. Then after some time, when there are no more problems, because, for example, some more resources are available on the edge again, the application, you will see the application will offload it back to the edge. And another nice point is that we will using two different infrastructures. So it will be Kubernetes and Docker. So just a way to showcase the different capabilities of the platform. So you have already seen this diagram before. So again, the workflow should be clear by now. And let's see the demo here. It's a bit long. It might seem long, but in the end, the key features that I'd like to highlight is that, okay, starting with the preferences expressed, so that, for example, a service provider might say, okay, I would prefer to keep my application here in my edge infrastructure, and then if it's really necessary, move some parts of my application on the cloud. So here we will see the first thing that maybe there might be constraints that might keep part of the application on the edge forever, and just one section of this application that can offload to the cloud. And so this first part is about the preferences. Then there is, of course, the part related to the definition of the SLAs with the guarantees or bunch of metrics and thresholds that you want may be alerted in case they are over that. And then, of course, there will be a bit of exchange of information with the different components so that everything is synchronized. We will start again the application. You will see that one of these is offloaded, as I said. And at some point, there will be the need to offload this part of application to the cloud. And here there will be the help coming from benchmarking the profilers that will fill basically some labels that will allow the DSS to choose which node is more fitting the needs of this application. And then, as I said, after this offload, we will wait for some time. There will be no violation, no warnings in the end. And this means that there are resources available again. And we will see the application going back to the edge. And everything is basically using the message buses coming from the stream handler. So applied to the specific scenario, everything I said before is with the two different infrastructures. So edge one that is coming from field based on Docker, and multiple cloud infrastructures, one on engineering, the other on I2CAT, both are on Kubernetes. The app are configured, as I said, and the app used is basically this media consumption that is made of two services. So one is constrained to stay on the edge, which is the energy consumption, and the other is the air consumption that should stay, let's say, on the edge. Maybe can stay on the cloud for some time, depending on, of course, on the SLA that are there. And in order to stress a bit the air consumption, we will use a tool. Of course, this is artificial, just to stress a bit the load, so that we will see this this service basically moved from offloaded, let's say, from edge to cloud and back. So now let me share the video, and I will just guide you through. 1 second. Okay, and okay, I think you can see my screen, just to be sure, I guess so. So again, the scenario, I've already discussed this. This is the diagram here, the same as before, and this is the demo that I've been already discussed, and the setup. So everything is set up, okay? Let's see the demo. Okay, so we start with everything that is described on GitLab. As again, there is all the documentation you want. Here you see there are no configuration on the different components from Pledger. So we start doing some logs and see that nothing is there. So we start everything basically, and we see there is nothing on the engineering Kubernetes. But at the same time, nothing, of course, also on sorry, let me stop again. Nothing also on Docker, so everything is stopped, as I said. Okay, let's see the network here that we are using, and it's a combination of edge and cloud infrastructures that with different nodes that are available, not big, but enough, let's say, for this demo. So the service provider prefers to stay on the edge, on edge fields. And let's see the availability here. Here we have this UI that allows us to have a bit of interaction with the configuration. And we have also the applications that are defined. Okay, and we will use the media consumption, as I said before. So before going with the constraints, let's see also the application that is done by two different services. And let's see the constraints. Here in these constraints, in a quite easy way, we kind of describe with a bit of rules which are our preferences. So basically we say, okay, we prefer to stay on the edge, or if not, we can go on the cloud, and this is applied with each service. So here is where we apply preferences with the services for each of the application. Okay. So once we have these constraints, we go on the deployment options and we read it in a more easy way. So we see that in this case, this service will stay anytime on the edge, while the other one will be, let's say, a preference to stay on the edge and can go on the cloud if it's necessary. I mean, this is a way to drive a bit the SS. This is, I mean, let me stress the fact that this is not the only thing that is used by the SS, because beneath there is this optimization applied. So it's just a way to guide it, okay? So here we see the console from the stream handler, where we see the messages that are exchanged. At some point, we go on the application, we see the services, we do some saving, and let's say here is the model that we use to describe the application. At some point, we go on the app. Oh, I'm sorry, first on the SLAs, of course, where we'll see the SLA that has been already defined with some thresholds. We just save it just to be quick. And with the guarantees, we have the different thresholds. In this case, if we go there in the edit, we see there is a simple query on Prometheus working on the CPU usage of Grafana. We see the message sent out by the stream handler. And in the end, all this information makes the other components be aware of the configuration. So there is a full sync, and by the E2Co, which is the orchestrator, and by the SLA Lite, which is managing the service level management, service level agreement monitoring. So we are free to go. So we can start the application. In the end, this follows the general indication from the service providers. We see the messages about the deployment happening on Kafka, on the stream handler. So the messages are sent, and using Postman, we can see that finally the application is running on Docker, so on the edge, on field site. And after, yes, we see the metrics is still very low, so there is no need to do anything. At some point, we start stressing up with the AB tool, and here things are fast, but in the end, what's happening is that we see the raising of the value of the metric coming from Prometheus. So at some point, changing a bit of monitoring of the, we change the topic on the stream handler to see that some SLA violations are sent. Here, of course, the stress is quite high, let's say, so basically it's catastrophic, and there is no need not to offload. So in the end, what's happening is that this information is received by the SS, and if we change again the topic, we see that the migration is triggered. So here we have the different messages that actually we also standardize so that we can combine also other components if needed. Now the application is no more on the edge. And if we go on the engineering Kubernetes, the application is there. So yeah, I mean, the offload has been achieved. And this is also tracked by the events, where very easily there is this choice of the best nodes. So in the end, the node between all those available coming from engineering has been chosen. And this has been done thanks to the benchmarking profiler data that is using the labels that I mentioned before. So if we go on the benchmarking reports, first on this service benchmarking match, we have the labels about what the benchmarks produced in terms of results that are used by the app profiler. And here, given the score computed, in the end, we found that the DSS found that the Pledger tree node was the one most fit for the application. And so thanks to these labels, in the end, there was this choice about the kind of node to be used. Okay. So if we now stop stressing the application, at some point, so here we will see that the video going a bit faster. yeah, so speed up a bit. We do the same, let's say, tour about the messages. At some point, we see that no more a new action is taken by the DSS, saying that okay, now it's time to there is no stressing situation, let's say, on the edge, so you can go back on the edge given the preferences that the service provider expressed. And again, you could see that, yeah, the application is again on Docker and no more on Kubernetes. Again, let me stress, this is a very basic example with just one bouncing between edge and cloud, with just one, let's say, strong situation where you have a catastrophic event with metrics of the thresholds, but just it's more to show you that, yeah, let me stop the the other demos. So this is just to show the ability of communicating and producing the entire end-to-end flow with the DSS trying to act as a coordinator about what to do in terms of scaling and offloading. Again, if you are curious and interested, there are lots of optimization algorithms back in the documentation and in GitLab and YouTube. You're more than welcome to check them and let us know if you are interested to explore them. And that's all from my side.
Okay, thank you, Francesco. We can move to the second demo for this slot that deals with the SLA mechanisms and the refund and smart contract mechanism.
Yes, hello. So in this demo, we're going to see a workflow in Pledger that starts from the SLA definition and ends up on the blockchain part of smart contracts and refunds. In this demo, this is the here we can see the basic functionalities and features that they are working, or some are working under the hood, and we will explain during the video, of course. And here we see the Pledger components that are involved in the demo, the service, SLA light, stream handled, slash bits, and DLT. We're gonna give, of course, more details on this. Again, a reference to the handbook and how this that is launching later, and how this is described in the handbook. And here, let's have a first view of the interactions that we're going to see in the video, actually, and how the SLA is actually defined or configured through the UI that we saw of the service in the previous presentation, and how this actually comes through the SLA Lite, and the definition is sent as a notification to the SLAS bridge. This kind of notification triggers actually the SLAS bridge, and on its part, it triggers the corresponding operations and smart contracts inside the DLT. And all, of course, the later functionality unfolds. Here we have again the scenario that we're going to see, and in a simple way, we're deploying the contractual terms of an SLA and in blockchain smart contracts, and we're through the monitoring of the SLA violations, we provide refund policies that are applied to the users involved in the SLA. And here the different steps we can see very quickly, and we will explain in the demo. We start from the SLA definition and configuration, and the SLAS bridge is identifying if there is a user and connects or creates a new account for the user. And afterwards, the main operation is that, of course, it encapsulates the terms and creates the dedicated smart contract that it's representing the new SLA. And from now on, since this exists in the blockchain network, the SLA violations are being notified to the DLT. We have the triggering of the compensation mechanisms and the refund operations on the network, actually. And let's go to the video. So we start from the definition of an SLA in the con service, and we configure it actually, and we have it deployed and sent actually through the stream handler in to the DLT. In the meanwhile, the operations in the DLT are the ones that we're going to describe. So the violations are being, the DLT is notified for SLA violations, and the corresponding actions are triggered. So for this SLA, we have now the creation of the new smart contract and the installation of it in the different nodes of the blockchain. And this, of course, happens through the SLAs bridge. And again, if the user of the SLA exists or it doesn't exist, the SLAs bridge performs respectively, of course. And technically, just to point that we have the security bus that the information is sent through to the DLT actually. And now let's go to the actual network. And here we can just see the smart contract that it is created. And the most interesting thing is that we are going to see now, and the application of the refund mechanism and how this works actually. So the idea here is that, okay, we have the user logging in and they have their balance at this point. So no violations at the time, but at this time, the DLT has received a warning violation, for example, because to make clear, there is, of course, different severity levels of violations. So about the warning violations, and we come again to the wallet. And what happens in the refunding mechanism is actually that according to the severity level of violation, different compensation is applied. And according, of course, to the user role, we have the SLA provider being punished and the SLA client being rewarded for the violation. So this is the balance of the provider we can see here, and the dedicated policy is applied. And this is the main logic, and we have, of course, different. We will see until the end of the video the different violation severity levels and how they apply. And this would be the main functionality and workflow we wanted to show in this video here and this demonstrator. The Pledger wallet at this point is in a very good state of development. We want to improve a few things. At this point, it follows the principles of existing wallets in the domain, and we hope we have a few opportunities in the future to keep developing it. So this is for Pledger now, and thank you for your time.
Okay, thank you, Nikos. I believe that it was a very informational demo in terms of how it would work on the business sense and in the real world. So let's take some time to take questions and discuss any aspect of Pledger that our audience wants to provide any questions or request any clarifications for. So I would pass the floor to the coordinator from ATOS.
Thank you, Olga. There was an initial question about the benchmarking of the applications that was initially answered in the chat, but I think that Alice and Gabriele can provide more details now.
Yeah, good morning, everybody. Yeah, as I said, if the question I got correctly, the question was about how we perform benchmarking more in detail. So we basically rely on third-party tools that are specialized tools for benchmarking, like Phoronix Test Suite or Sysbench, iPerf, and we have a mix of let's say micro benchmarking that are specific for some resources, like to measure the CPU or the network, but we also integrated some more application level benchmarking that I mean, try to simulate real world applications like databases or scientific simulations or yeah, any type of different application, and so we execute all of them in the different infrastructures and in the different nodes of the infrastructures to be able to assess the performance of each infrastructure on with regards to that particular workload, that particular benchmark, and this allows us later on to somehow rank the different infrastructures on the basis of the performance for a given workload. And the key point here is that when the user comes with his own application through the profiler, we are able to understand the behavioral of this application, and so to understand also which is the best benchmark to use for that application. So if it is a, I don't know, a CPU bounded application or a network bounded application, and so this is information that we use to match basically an application with the benchmarks that we performed earlier on the infrastructures, and to find the most suitable node, the most suitable infrastructure to run this application. And yes, also we mentioned, I was mentioning in the chat also the fact that we support different infrastructures based on yeah, different technologies like Kubernetes, Dockers, and or beer virtual machines or devices accessing it through SSH to execute the benchmark. So we did a model of the different workloads, and we are able to execute exactly the same code on the different infrastructures. I hope it answered the question. Otherwise, yeah, please specify better. If you need more information, we can answer.
Are there any other questions from our audience?
I can also answer the part of for the profiler, because it was a two-part question, I think. As far as the metrics that we use for the profiler, basically every application, especially containerized one, because the application profiling regards containerized application. This means that we take advantage of the namespace type of resource allocation that this software provides, especially Docker, of course, and Kubernetes, because Profiler can work for both these principles and frameworks. So the resources that we monitor are basically the typical resources you find in a computer system, of course, the CPU, the RAM, the network, and also the input and out operations in the storage. And basically from these resources, we gather metrics, and basically we create a lot of different parameters in order to profile and create a profile of an application based on the consumption and the footprint of these resources of the specific application. And this profile is considered for both application and benchmarks in order to create the correlation needed and the classification of application to specific benchmarks. That is all from my side. I hope I cleared the question.
Any other questions for the presenters? I suppose. Yes, Lara?
No, I was saying that seems not, and there are also no other questions in the chat.
Okay, so you can share your impressions on the features that you have shown demonstrated today in a poll that we have created. This is also anonymized, so you are not going to be sharing any personal information within the poll. It would take 5 minutes, and we would be grateful if you could provide some inputs in this form. So I have already put it in the chat box, and let's give it some time. We are slightly ahead of schedule right now, so let's reconvene at 2:30 so we can move forward with session 2 that will deal with the integration fabric and the use case of measurable benefits that we have observed. Services.
Sorry, just realized that I was muted. So my name is Panos Matzakos. I'm a research and innovation engineer at net company INTRA. And I'm going to present you the framework that we used in Pledger for the software and data integration. So our objective at the beginning of the project was to follow a well-established and efficient framework in order to be able to continuously integrate the software outcomes, the developments for the different components, and deploy the updated software artifacts in two different environments: the development environment, which was used for the initial components testing, and the production environment, which is part of the Pledger integrated platform, and which is also used for the pilot's execution. So another objective was to ensure the interoperability among components and the efficient integration in the Pledger platform, and finally to ensure that the flexible deployments of the project artifacts and their in a manner that can ensure their replicability in different types of hosting environments. So some basic guidelines based on these objectives that we followed for the integration framework was first of all to follow a containerized components approach, meaning that we wanted all the software artifacts to be in containers form and follow a deployment based on microservices in an orchestrated environment, as this can promote scalability and fault tolerance, as well as better support for DevOps operations in the sense of supporting in a more native manner automation in the deployment, fast deployment, and testing isolation of the different components. And finally, as I said earlier, also our target was to have a transparent way of the different environment that is hosting the different applications, in order to promote replicability of the components and the whole platform itself. We also, regarding the integration patterns, we wanted to use common and widely adapted interfaces and protocols for the data and information exchanges among the components. And we were mainly based on REST APIs over HTTPS and the use of a stream handler platform, which is based on Apache Kafka, and which you have already heard a bit from the previous presentations, and I'm going to provide some more details on the second part of this presentation today on how it works. And finally, the use of common and widely adapted data formats in the exchanges between the applications was another guideline that we followed, and this was mainly focusing on JSON types of file formats. So when we think of the integration environment, you should think of it as from a developer's view and from the users or infrastructure provider's view. So on the left-hand side, you can see the developer's view, which is based on following best CI/CD practices, where we support automation procedures based on starting from the developer pushing his or her code in GitLab repository, and then through Jenkins we have some automations in order to build the artifacts of the software components, the Docker images actually, and push them in a container registry, and then on the development workflow, deploy them on the development environment, which is based on Docker containers, in order to be able to run some tests. And the deployment workflow that you can see in the bottom, then, for example, by merging with a master branch of GitLab repository, Jenkins triggers the pull of the image from the container registry and its deployment in the production environment, which in the case of Pledger project, it was hosted from engineering, and it's based on Kubernetes. Where you can have all the fancy stuff with respect to orchestrating the deployment of the different components. And on top of that, we have the stream handler platform that is used in this sense as a middleware backbone for the exchanges between the different components and services. And I'm going to provide some more details about that later on. So here you can see some snapshots of the CI/CD software tools usage. We were happy to see that all the component providers actually followed the whole CI/CD pipeline, meaning that they were also providing their codes that you can also find in the public GitLab repository, which was set up in the project. Some links have been already provided for specific components in the chat. Then we have Jenkins, and here you can see all the automated pipelines that were set up for the project. JFrog Container Registry, there were on the left-hand side, you can see the different repositories that are keeping the images of the different components. And finally, the Portainer showing a view of the management tool that we used for the development environment that was used for testing. Moving on now to the Stream Handler platform. Stream Handler is a high-performance distributed streaming platform, which is based on Apache Kafka for handling real-time data. It is interoperable with all types of modern data storage technology systems and with persistent storage approaches. And I already mentioned its main use in the Pledger system, which is acting as the backbone middleware for efficient communication among different applications and services. But apart from that, it was also used for large data transfers in the edge cloud continuum, as you will see later on in different use cases presentations, and also for exporting application metrics as well for the different project use cases. The main innovations which the Stream Handler platform brings to the project is the high throughput and low latency messaging, which allow for real-time monitoring and event processing. The integrated connectors that run on top of the Stream Handler cluster, the Kafka cluster, and allow the interconnection with various types of external data sources and data storage technologies. The way of function of the Stream Handler platform, which is based on a producer-consumer approach that offers transparent and asynchronous transfer of information. And the whole system is secured with strong security and authentication authorization mechanisms, for which I'm going to provide an overview. And finally, it natively supports the integration with modern processing and ML frameworks. A few words about the architecture of the system now. So here you have the Kafka cluster, where you have which is the heart of the system. The data there are stored in the brokers in streams of messages, which are organized in topics. The producer-consumer approach is supported, and its capabilities is that it can support up to hundreds of thousands read-write requests per second, and supporting the real-time handling of data, as I said before. And in the context of Pledger, we had 3 brokers which were set up to achieve load balancing, redundancy, and fault tolerance. Here in the Zookeeper quorum, you have some Zookeeper nodes which are used in order to manage and coordinate the Kafka cluster. In the schema registry component of the platform, you have the component that is responsible for the creation and storage of data models in order to describe the data. This is based on a RESTful interface for storing and retrieving schemas based on Confluent, and the data formats that are used to describe the models are based on Apache Avro, which is an unreached JSON format, actually. Kafka Connect is built on top of the main producer-consumer API of Kafka in order to connect external systems, as I said before, to the platform. The REST proxy is used in order to be able to, as an interface based on REST API, in order to be able to easily produce and consume messages, and as well as perform some administrative tasks relative to examining the cluster status and the management of topics, for example. And the UI and monitoring node is a collection of open source tools for cluster configuration and overview of cluster performance and health status, based on software like Prometheus and Grafana. With respect to the supported scenarios in Pledger of the Stream Handler platform, you've already seen in the previous demos some interactions of the stream handler platform, for example, with the DSS and the core components. So I'm not going to also for the configuration service and the IDPS. So I'm not going to stay here. With respect to the supported scenarios in the different project use cases, so Stream Handler was used as a supporting tool for all three of them, mixed reality applications on the edge infrastructure for enhancing safety vulnerable road users, and manufacturing the data mining on the edge. And you're going to see some more details later, of course, in the use case specific presentations, but just to give you an overview, Stream Handler was used in the case of use case 3 from transferring data from the edge to the cloud and to support applications offloading in case of limited exposure of services. The export of application metrics in the case of use case 1 and 3, where the Stream Handler exports the received application metrics to a central Prometheus monitoring framework of the platform. And finally, in the case of use case 2, the transfer of users' position logs data towards blockchain's DLT through specific message topics. And finally, just to give you an overview of the security best practices that were used under Stream Handler platform, the objective was to protect confidential information while the platform is used from different teams and software components. And in this context, 3 layers of security were applied. First, the encryption of data in flight between brokers and clients using SSL protocol. Authentication policies applied on top of SSL so that only clients from trusted IPs can be authenticated to the cluster. And finally, authorization based on access control lists, meaning that once the clients get authenticated, the Kafka brokers can check the access control lists in order to decide whether a specific party, a specific client is eligible, is authorized to read the specific content, which is translated in a Kafka topic, actually. And that concludes my presentation. Thank you all for joining again.
Okay, many thanks, Panos, for this presentation. I believe it is very important to show not just the part about the technical innovation that came out of the project, but also the part how this innovation can be integrated together, not just in terms of software, but also in terms of data in a way that makes it production level. Which is something that we had in mind in the early stages of the project, that we were going for an architecture that was as close to production level as possible. So let's move on to the next set of presentations on the use cases, on the real world use cases that we use the Pledger core systems with, and also to bring to your attention the kind of benefits that we have measured for these use cases. So let's start with the first use case that deals with mixed reality applications from HOLO.
Hello, thank you. Hi, so my name is Karina Pumming and I'm the Chief Project Manager at HOLO.
You are muted, Karina.
I'm muted.
Oh, okay.
Can you hear me?
Sorry, I probably have a problem with my
Yes,
sound.
we can
Sorry.
hear you.
Okay. Okay, let me quickly share my screen. And also, excuse the robot voice, that it's actually my voice. I'm a bit unwell. Okay, can you see my screen?
Yes.
Perfect. Okay, so as we already said, so we were use case 1 provider, so mixed reality application on the edge. So what was our motivation? We wanted to leverage the edge computing technologies that are being provided by the Pledger Toolkit to increase the performance of the augmented reality applications in an industrial environment. We had, within our use case, we had 3 sub cases. One of them is collaborating in fast prototyping. So here it was really the visualization of 3D CAD models and the interaction with them in a shared environment. So with between 2 to multiple, I think up to 50 people. And assisting in manufacturing and service utilities processes, so in short, fast remote support, and enhancing training and interaction. So a training application, essentially, solution. The problems that we were facing at the beginning of the project is that the marketed AR devices have quite a bit of a constraint when it comes to computational power. And then we were looking into a dynamic modification that would, dynamic modification of certain values to increase either the speed or the performance, to reduce latency, just to have something that is adaptable and that improves scalability throughout the processes. I think somebody's not muted and I can hear kids in the background. Yeah, thank you. And the next thing was, of course, especially because we're working together in the industry project and industry area. So the security aspect was very, very important to us. So here we wanted to have a strict and a robust security measure, especially during the time when there's a trade between the industry, the 3D data. Now, on one side, the solution, it is something that HoloLight is generating. This is the remote rendering solution, which is essentially splitting the rendering process. So you have the whole application is rendered on an edge device and is then streamed over to the for example, the HoloLens or the Oculus Quest 2 or an Android device, whatever. This was one side, but the more important side actually was the integration with the Pledger framework. And this is then the final result. So in use case 1, we are actually utilizing all of the components, of course. And how does it work? So you have Aries and Iser together, integrated into the Pledger framework, creating the Pledger workspace. And that is connecting via the client to the, in our case, we use the HoloLens. And so the application itself is running on a VM. It is, and the VM itself is controlled by the orchestrator and is connected via Kafka to the recommender and benchmarking tool. So, and what is happening, so the recommender is monitoring the values to the criteria that we have set. And if there is a violation, it communicates that violation to the orchestrator that would then trigger either the launching of a different VM, so to increase the processing power, and also apply changes to the bandwidth directly through an API setting to reduce latency and to improve the visual quality of the image that is being observed. Which is in AR technology very important, because if you have poor image quality, it actually really strains your eyes, which makes working with the tool a bit more uncomfortable. Now, the security aspect for us was then also, of course, the integration into the DLT, where we're using the Whisper protocol, the Ethereum Whisper protocol, to secure the connection between the client application and the Pledger workspace that is running on the VM. So the pilot deployment for use case 1 that was performed on Phil. So thanks again, Phil, at the industrial premises. And throughout different stages, we have tested both, those are all 3 sub cases. So the fast prototyping, remote support, and the training aspect. Now, what we have found, the benefits of Pledger being, so Pledger, the Pledger framework really enables the stakeholders to achieve an even faster and more powerful visualization of 3D CAD models. As I said, that especially through the orchestration and the recommender controlling the bandwidth. Yeah, it had a huge impact on that one. It allowed us to display more complex 3D models with higher performance in a real world environment and also in a scalable environment. So you don't have to start using the most powerful VM. You can actually adjust it based on the files that you intend to use. It offers the possibility to have an even secure upload of confidential data, and it enhances the experience, of course, of the mixed reality collaboration session. Again, that's the bandwidth control, and actually also the file loading aspect of it. Yeah. What is the result? It's more cost effective. So we have found, yeah, we'll talk about the results later. There's a reduction of current cycle times, simplification and standardization of working processes, and there's a fast and even more intuitive training process for new workers, which will have which has an impact on the onboarding time that is necessary. Now, this is the training scenario here. You would have, you could load the file, you can directly interact with the 3D model. You can have the, as you can see in this image, you can also have the documentation displayed in space. So it's easy for you to learn how to build, how to do something, how to practice something that you are unfamiliar with. And the next thing was remote and fast prototyping, the remote support and fast prototyping. The technology here is very similar. That's why we've put them together, even though the application is very different. In remote support, you can do your thing on the machine and you realize something is wrong. And then you can call in and ask somebody to help you. You would see the avatar in that shared session, and you will be able to follow the instructions the person is giving you. We're currently in preparation of a video that will better showcase this scenario. And then also, of course, fast prototyping, as I already said, you can take the 3D model, you can take it apart, you can have multiple parts overlaying, see whether something works. And in a collaborative session, you don't have to be on the same premises. You can be in different locations. It's really cool in that regard. So yeah, those were the environments that we've tested or the Pledger framework under. Now the results. So we had quantitative results and qualitative results. The quantitative results were like technical metrics and measured data, and the qualitative results came from the end users, IT personnel, management surveys, and developer feedback. Now the quantitative results. So we loaded CAD files in the size of 236 megabytes for 156 and over 1 gig. Loading in a machine with 4 CPUs, 4 GB worth of RAM, and had initial loading times of 7 minutes, so 7.9 million minutes, 5 minutes, 26 seconds, and 4 minutes. Now, the violation was triggered. And then after implementing the Pledger framework, there was a violation triggered because these are, of course, are very unacceptable loading times. And what happened is a VM was started with 8 CPUs and 8 gigabyte worth of RAM, which decreased the loading time to 4 minutes, 3 minutes and 2 minutes, which means there was pretty much an almost 50% reduction in time. As I said, this is cost effective. You are not wasting time waiting for a file to load, if it loads at all. Now, latency measurements were also comparable across trials, indicating so whenever a violation was triggered, with the bandwidth mediation was successful. So the Pleasure framework picked up that there was a violation, changed the bandwidth setting, improved the quality, and the person on the receiving end, so observing, they didn't really even notice how much was that, that there was a lot of thing going on. So it was a pretty fluent experience. Now, the blockchain security enhancements were also successfully implemented and are securing the connection. Now, the qualitative results. So we've talked here, as I said, with developers, end users, IT personnel, and management. The feedback from the developers for Pledger. So on their end, they said the integration of the Pledger components was quite smooth. So it was very also speedy, so that it was not particularly difficult to integrate. The actual development team rated the Pledger overall experience, so the overall experience with the Pledger framework, with a 4 on a 5 scale, on a scale of 5, and I'm very sorry. Yeah. So the integration of the Pledger application was generally considered very favorable. So the entire process was perceived quite well, and this ranging from the conceptualization phase, the integration phase, and the implementation phase. So that was in general very, very good feedback. Now the end user feedback. So the users on an average reported that the AR use, so the augmented reality use case in the workplace, provided them a better training or a better instruction method than the traditional ones. When asked how likely they would actually like to continue using the technology on a regular basis, they indicated a very strong likelihood. With respect to quality of the AR experience, they noticed some reduction in quality of the virtual objects, but nothing substantial that would kind of prevent them from continue wanting to use it. And the users also indicated a considerable enjoyment with the application, also the ability of having this collaboration. And they also saw like that is a much faster method than the current methods that they can use, especially in the support case where it's usually a lot of back and forth. And in our case, it was actually just a ring, and then the person could already see everything and find the solution. So there was a very very short turnaround time. The IT personnel, when talking, so we talked with the IT personnel in regards to what difficulties they would have when they would run out a system like the Pledger framework, and their response to our question was that the Pledger framework would be beneficial at the workplace in general. They pretty much like the whole framework, particularly the ability to have customizable validations, so they could really set their own metrics, and being able to also upgrade and modify the performance, as in our case, was something that they really appreciated. The IT personnel also indicated support for potential future use in terms of coordinated upgrades. So at the moment, rollouts would mean one person dedicated for maybe several weeks. There are multiple tests to run, very small staged groups They were being used for a rollout, which could then there were also considerable times when people were not able to actually then work with the devices. While this is a very centralized approach with the Pledger framework, which actually then resulted in they will be able to stage the process outside of working hours, and it being centralized, brought essentially just a lot of benefits to them. And also they wouldn't need to have a dedicated person just going from device to device to device. With respect to limitations and constructive feedback, so there was indicated that the setup, especially the thing that they very much liked, is this the modular, the ability to set their own violations, but also means the setup at the initial stage would require a larger time frame. Now, management indicated a very favorable view of AR in workplace in general. With respect to the Pledger, they noticed that they would have to do a cost-benefit analysis before they would actually be able to decide on the implementation. And here the emphasis was placed on the feedback from the employees and the customers and their willingness to adopt the technology. So it was really, is there an improvement? Like, do people want to work with the tech? Then we would consider it. Do people not want to work with the tech? Then we would not. And that's pretty much, that concludes use case 1.
Okay, thank you, Karina. I believe it was very important to see the vast improvement in terms of loading times and how important this is for an industry that deals with mixed reality applications. So let's move to use case 2 on vulnerable road user protection by ATOS.
Good morning. Good afternoon. Can you hear me and see me?
Yes, can you please full screen your slides?
Yes, sure. Of course, I will do that. So thanks a lot, Karina, for the overview of use case 1. I will continue with the second use case, which has been deployed in Barcelona. And here we are dealing with improving an application or improving the safety for micro-mobility users using a Pledger and a dedicated edge infrastructure. This use case has been carried out by ITOS. I'm August Betzler. My colleague Estela Carmona will also be presenting, and we have done this together with the City Council, in short, IMI. So what is the use case about? The title of the use case is Edge Infrastructure for Enhancing the Safety of Vulnerable Road Users. So let me explain what this is actually all about. When deciding to implement this use case, we thought that it would be that it's still necessary to improve the safety of vulnerable road users. A vulnerable road user includes pedestrians or users of micromobility, such as bicycle drivers, electric scooter drivers. And what we want to do is implement something that can detect possible risks for them and to alert them of this risk. So we looked at the city layout. We tried to find some places where this could be helpful, the use of ICT infrastructure, and we found several locations where the layout of the bicycle lanes, the pedestrian lanes, and the public transport can be sometimes confusing and can generate certain risk. Now, there are a lot of things there are done to improve the safety by regulatory means, but also by improving the infrastructures. But with modern technologies, state-of-the-art technologies, we can improve the safety further. So what we did is we picked one of those locations, and you can see here on the left image the bird's eye view, and on the right-hand side the photo of this location. This is the Diagonal Street where we have tram circulating. There are 4 or 5 tram stops where we have the layout shown on the left-hand side. We have a situation where pedestrians always have to cross the bicycle lane to get to the tram stop, where whenever the tram arrives, there's a flux of people entering and leaving the tram. Now, this, while there are some indications to be careful, this is a potential risk. So we decided to equip the bicycles and electric scooters with a gadget that we developed in a project, which is capable of connecting to the infrastructure that we deployed for the project. This infrastructure uses vehicular communications, IEEE 802.11p, and this allows us to share locations of the users, of the bicycle users, with the infrastructure, and from there on, it can be sent to the edge servers where we run our applications. Now, the interesting part here is that we are using Pledger to manage and orchestrate the service, this risk detection service, and that allows us to implement the necessary quality of service and also quality of experience. Now, 1,000 words can be replaced easily by a video. Let me briefly show you what the situation is that we are dealing with on streets. So here you see a camera attached to an electric scooter driver. Sorry for the angle, but I tried to correct it, but then you wouldn't be able to see this gadget on the right bottom side. So we are approaching the tram stop, and this gadget, which uses LEDs and a buzzer, alerts us already, like in warning, to be careful. Then as we approach further, we get a critical notification. Here, the driver is requested to be extra careful, because as you can see, people are, you see this lady, she just crossed with the phone in her hand. She might not pay full attention. Here, some people are using the lane. So the idea is that we can warn the driver here to be careful when they approach a tram stop, and to accelerate, so to hit the brakes. And once we leave this area, the warning stops, and we can continue driving. So having said that, let me briefly show you what we did in the pilot and the preparation. So first of all, we had to execute many repetitions. There's a lot of fine-tuning to be done on street, like testing the connectivity, the radio connectivity, tweaking these danger areas. So we have a warning and a critical warning area. We adjusted them so that the perceived warnings are always generated on time. We also had to tune the gadget, which the loudness of the buzzer, how the LEDs are blinking, and what they signalize to the driver. And finally, we had a whole effort of the remote team who was testing the slicing and system monitoring. All the benefits that Pledger brings that are relevant for this use case, like minimizing latency, assuring that any logs or about the position of users are kept privately and can only be accessed by trusted users, as well as assuring that the service is always available, because this is really relevant in this use case. We are dealing with the safety of citizens. This is explained by Estella later on in detail. So let me tell you that we did 2 iterations of the pilot. We called them trials. And we had our teams from the project, but also 10 participants with different types of background, technological, non-so-technological. And we brought them to the location, which is Fluvia tram station in Barcelona, to participate in this pilot. So we did a 20 minutes presentation where we presented the project to them. We had a coffee together. We did Q&A sessions. So the idea was to really explain to them what the project is about, what the use case is about, and what they are expected to see on street, which is supposedly that the service works flawlessly, right? So we executed this scenario. We had some volunteers who ventured on the scooter. They were asked, both the ones that were on the scooter and the ones that were staying at the tram stop, to pay really close attention to what they saw, what they listened, and here this cut off. And also to check if they perceived that in some way the service was interrupted or not. And why is this important? Well, after all, Pledger is running in the background, and it's doing a lot of things to optimize the performance and to ensure that it's running. So we want to know from them later on in the questionnaire that we shared with them, whether they perceived that this was that they saw something happening, or if it was seamless. And here we got really good feedback. Overall, we got a score of 4.75 out of 5 from the users. Here's just some comments that we picked to highlight what they saw. So they didn't actually notice Pledger doing things. So the experience was very seamless. For them, they just saw a functional use case. And also, they said that there were really useful features, scaling, smart placing of applications, and also what sometimes like it's not seen during the execution, but the fact that we can configure an entire infrastructure which is deployed across the city, as Stella will show you in a moment, is really important, that you can do it on the press of a button. So these are really the benefits that Pledger brought us here. And with that, let me hand over to Stella.
Hi, thank you very much, August. Let me share my screen, just 1 second. I hope you can see my screen. So like August said, I am going to elaborate on the main benefits that Pledger brought to our use case. And these benefits are fourfold. So first of all, we've got the infrastructure management.
Sorry, Estrella, can you stop sharing and try again? Because we cannot see your entire screen. Something is glitching.
Okay, you cannot. Let me try again.
So maybe
I can only see a brief strip, but not the entire slides.
Okay, let me try again. Is that better now?
Yeah, yes, now it's working,
yeah.
Stella.
Okay,
You can put it in
sorry for that.
presentation mode. We can no longer see you, but we see the presentation, so yeah.
Okay, that's great, thank you. Actually, I'm having some problems with my camera, so I will leave it off for now so that you can see the presentation. So as I was saying, the benefits.
Can you please make it full screen first? Sorry, thanks.
It is full screen. Can you not see it in full screen?
No, it's we see it in editing mode.
Okay, what about now?
Still editing mode.
Okay, just 1 second, sorry for that. Is that working now?
No, we saw you clicking on the present icon, but it's not opening the the presentation view.
Okay, maybe you can share the presentation, August, if you've got it.
That's the thing. Just let me check, because is it the one that is still online, or?
Yes, it is. If not, let me try something else again, and if not,
yeah, if you can send it to me over a Slack, then I can also present. That's
okay.
No problem.
Estela, maybe you can try. I don't know if you try to press the slideshow icon on the bottom right of the PowerPoint.
Yes, I did actually, and for some reason it wasn't working.
Oh yeah.
Is it better now? Can you see the full screen mode?
Yes, but we can also see the comments on the right.
Okay. So now you can be able to see it. Okay, great. Sorry for that. So yes, I was going to explain that the benefits that Pledger brought to our use case are fourfold. So the first one is in terms of infrastructure management. This is managed through network slicing in Pledger. Then we've got smart contracts, management of sensitive information, and the management of critical application delays. So let's start with network slicing. Network slicing brings a few benefits in our use case. First of all, because our citywide infrastructure is shared among different stakeholders, it's also of a heterogeneous nature.
with different types of nodes, for example, radio nodes and computational nodes. And it is also distributed across the city. So the SOE and RAN controller modules in Pledger provide the network slicing functionality here. The way it works is that through the COM service dashboard, the user can trigger the deployment of a network slice, and then the orchestrator will communicate with the SOE and RAN controller for the deployment of the network slice. And we are going to end up with a dedicated network slice with dedicated resources for our use case and with end-to-end connectivity. And all of this can be achieved in a very time-effective manner. This is an overview of our slice setup. In our use case, we are using a Kubernetes-based infrastructure, and we are going to deploy a number of software modules that we need for our vehicular slice to work. That's what we refer to as containerized V2X stack here. For the V2X functionality to work, we also need to set up 2 radio nodes, which are based on IEEE 802.11p technology. And we need to set up the appropriate networking between the radio devices and the rest of the infrastructure, and also the software components that conform the V2X stack. All of this also needs to be seamlessly networked to the risk detection and notification system that we use in our use case. So through Pledger, the required resources for the use case are reserved. The required networking and interfaces are automatically configured. We manage a cloud-native deployment of our V2X stack, which is made up of containerized modules. And also we achieve end-to-end connectivity between roadside units and our risk detection and notification service. Service. So as you can see, it's pretty straightforward. The user only needs to configure a few parameters related to the computation of resources for the network slice. Then at the touch of a button, the slice will be provisioned in a matter of 1 minute. This is an overview of the performance improvement that we are getting when using Pledger in terms of time as compared to the time required for a manual deployment performed by expert engineers. So as you can see, with Pledger, it takes around 61 seconds to deploy and slice, whereas it would take an engineer around 720 seconds to deploy a network slice manually. The time to deploy is 11.8 times faster, and also we are avoiding many human errors related to misconfigurations that can happen during the process of setting up the network slice. The first step when a network slice is provisioned is the creation of a compute chunk, which in our infrastructure is deployed as a Kubernetes namespace with a given resource quota of our choice. Then we also use OSM for the initialization of the V2X stack components. And OSM provides valuable functionalities, such as the deployment of network services and network functions, which are standardized according to ETSI. Relevant radio parameters and interfaces are configured on the roadside units, as long as all the required networking parameters, leveraging the use of Open vSwitch. To bring the attention to is the definition of smart contracts. So in our use case, the risk detection and notification service has some requirements related to the availability. In Pledger, we create smart contracts in which we define some contractual terms related to the availability of other parameters. And then we implement some SLAs, which basically are metrics related to these valuable parameters that we need to consider. We constantly monitor these metrics through the monitoring engine in Pledger, and when we reach a violation, then a refund is actually automatically calculated depending on the severity of the violation of the SLAs. In our case, the main SLA we are interested about is the application availability, which is constantly monitored by the monitoring engine. Depending on non-availability of our application, the refund policy is going to be different. So for cases where the application is unavailable for more than 95% of the time, we are talking about a catastrophic violation. And here you can see just a very descriptive screenshot of what happens. So if the application status goes to 0, as you can see on the graph, then the service availability eventually starts dropping, and a notification is sent out through the stream handler, and then it is received by the smart contracts. According to the severity of the violation, then a refund is added to the smart wallet's balance. In our case, our smart wallet represents the totals due to the infrastructure provider. And since there has been a violation in our service availability, the refund is subtracted from these totals due. The third main functionality from Pledger is the management of sensitive information. So in our use case, we've got a risk detection and notification service, which is constantly generating sensitive information related to the position of the application users and the timing of those positions. In Pledger, the DLT retrieves these logs, which are generated from the application side. And these position and event logs are then securely stored in the blockchain, ensuring that only authorized users have access to the logs. So as the use case application is periodically generating these logs, which include the anonymized user position, the detected collision risk, depending on their position and the timestamp, these logs are automatically sent to the stream handler. And since this must be securely stored and only be accessible by trusted parties and users, these are stored in the blockchain, and they are retrieved by the DLT. So the main benefits that we obtain are that data is securely stored, and then authorized users only have access to relevant and anonymized statistics. So as you can see in this screen, an authorized user could perform a filtering of events. In this case, we have performed a filtering for a time slot of 12 hours, and they can get some information related to the number of critical and warning situations, and also the number of no-risk situations during that time slot. And last, another functionality from Pledger that is critical in our use case is the management of the delays in the case of a critical application. Since we are running an application of vehicular type, there are some requirements related to the delay, end-to-end delay, that can be achieved, and that is permissible to guarantee the correct functioning of the application. In our case, when the service is running with a high number of users and a set resource allocation, delay violations might start arising. These are monitored by the monitoring engine. So the delay is constantly monitored by the monitoring engine in Pledger. And anytime a delay violation arises, this is detected and notified by the SLA light. In turn, the DSS will perform an scaling action to change the resources allocated to the application. We have tested the delay performance of our application under 3 different scenarios. For a first scenario, we had scarce and fixed resources. We didn't apply any scaling. For the second scenario, we had extra fixed resources. Also, we didn't apply any scaling, but we were able to demonstrate that by giving the application extra computational resources, then we get an improvement in terms of delays achieved. And then in the third scenario, we applied the scaling algorithm provided by Pledger. So we had variable resources. And what we found is that when we applied the DSS algorithms through Pledger, we achieved both a reduction in the resources assigned to the application and on the time delay achieved with respect to the second scenario where the application was over-provisioned. So the average delay was reduced by 4.8 times with respect to the first scenario and by 2.75 times with respect to the second scenario with extended resources. And we also got an average reduction of 10% of the CPU usage with respect to the second scenario and an 18% reduction of the memory usage with respect to the second scenario. All of that while achieving a better average delay and a reduced number of delay violations. And that's everything from our use case perspective. So thank you very much.
Okay, thank you, Estrella. I think it's quite important to note that all the Pledger use cases have very distinct and unique characteristics. So whereas the first use case dealt a lot with the loading times and ensuring the best outcomes in terms of bandwidth and loading. The second use case was critical in other respects, like latency and reliability. And the third use case will also showcase some results in terms of overall reliability, and it was one of the most critical use cases in terms of security because it dealt with confidential data in manufacturing. So let's move to the third and last use case of the day on data mining on the edge for manufacturing applications, presented by Phil.
So hello everyone. Sorry, was there a question? I just heard something in the background.
No.
Okay, so my name is Verena Stanzl and I'm working at Phil as a data scientist, and I will show you today use case 3, which is data mining on the edge for manufacturing. So let me share my screen so you can also see my presentation. So I guess you can see it now in presentation mode. So just a short introduction to also give you the framework and all the domain. So Phil is an Austrian mechanical engineering and plant construction company. And we are building machinery and plants, especially in the automotive, wood and sports industry, but also renewable energy sector. And in this use case, we are dealing with synchromill machines, which are cost-effective and innovative machine concepts dealing with large quantities of parts to be produced. So these machines are usually used in a 24 hours per 7 days scheme, so in 3 shifts with high level of precision, so up to 0.01 millimeters. So we have to deal with large quantities with high accuracies And we are producing on this machine cylinder heads, battery trays, etc. And also to guarantee these high quantities and high accuracies, we are dealing in this use case with process stabilities, and these process stabilities are characterized by stable media consumption, so stable air and stable energy consumption of the machine, but also the stable product quality, a stable product cycle times, so that every product is manufactured in the same timeframes, but also the thermal stability of the machine is crucial for our experts here. So we developed applications in this use case to help the manufacturing experts to determine this process stability, and also the determination of the thermal stability is of high interest for the machine operator, as due to thermal influence, the metal components of the machine are extending, and this has a high influence on the accuracy and quality. And that's why machine operators are usually doing some warm-up processes before they go actually into production mode. This means they are moving the machines in the different axes for several hours, usually for one shift, so for 8 hours, just to guarantee that all metal parts are extended on their furthest, and they can guarantee the accuracy of the machine. So we developed these applications to determine all these stabilities, and they are deployed on an industrial PC, which is acting as our edge device, which has the advantages of being robust and also being small, so it can be installed in the control cabinet of the machine. But of course, it has also limited resources. So for Pledger offers us now the following benefits. So we can manage our infrastructure and also do the service orchestration. We can monitor our performance, the quality of service, and the SLAs. And we can benchmark our infrastructure. We can profile our applications, and we can also manage securely the sensitive data which is produced during the process. Just to give you a short overview, you can see here a little bit of an insight on how this machine works. So this is how such a part is manufactured, to give you a short overview on what we are dealing here with it. So the first part is to determine the stable media consumption. So these are just two containers to analyze and visualize the media consumed by the machine over time. So you can see here the air consumption and also the electrical power. So this is a very stable process, and we are using Pledger to orchestrate these services, and also to use them for the offloading scenario I will present afterwards. So the more complicated process in this whole use case is the automatization of the warm-up process. As already explained, so this warm-up process is necessary to ensure the quality of the parts we produce in our use case, and the duration is often unknown and is also set to experience of the machine operators on how long they actually have to do the warm-up process. So our goal was to automatize this whole thing and rely only on data of the machine, which can be mined on the edge, and use our product, which is cybernetics analyze, to process and to actually automatize the determination of the thermal status of the machine. So we can gather from data on the edge the thermal stability of the machine. So the machine performs one warm-up cycle, sends the data to the application to determine the thermal condition of the machine, and afterwards the machine waits for the results with the instruction on the further proceedings, so whether it can already go into production mode and produce parts, or it has to continue with the warm-up cycle. And we gained from our experiments that this waiting time should not exceed 90 milliseconds. So we have to guarantee the delivery of the result of 90 milliseconds. Otherwise, the machine operators are not sure whether a machine is still working, or there is a serious issue with the machine. And we would like to guarantee exactly these 90 milliseconds. So we are now supported in this use case, of course, with the service orchestration, so we can deploy our media consumptions services, but also the thermal stability app. We can monitor the performance of the queue, the quality of service, and the SLAs. So we can guarantee these 90 milliseconds I was talking about. So if we are experiencing a decrease in the performance, we can automatically offload another application to the cloud based on decision making, and we can also use smart contracts in this use case. So one of the first advantages is the service orchestration and performance monitoring. So it's very easy, and this takes a lot of manual steps from our side. So we can just monitor and see our infrastructure on this network, where you can see we have here our edge and one of our nodes. We can then afterwards just also see our infrastructure here, configure it, and basically that's it. So this everything is taken then in the back. And now we can also see the deployment options for our application, so we can configure where it can be deployed. So if first on the edge, so we would like to have it on our edge, but also in case it needs to get offloaded, as we need to guarantee our 90 milliseconds, you can also have some other deployment options in the cloud. And we can see we can here now manage our application. If we hit start and we save this action, and we can just wait until the container here appears. So this is very, very easy for us. Yeah, and it's there. Perfect. So let's just move on to the next one. So afterwards, we can monitor the performance of the thermal stability component. You can see here where we have some lower loads on our edge device, and you can also see here the calculation time. This has, of course, some variance, but basically we are lower than 90 milliseconds, way lower than 90 milliseconds, except for some peaks. But as soon as the device is on load due to other processes running in the back, we can also see that we cannot guarantee this 90 milliseconds anymore. So we are way above this threshold. And that's why we need to get and free some space on this edge device and offload another application to the cloud. And this is what you already saw in the core system demo. So this is, I will just summarize quickly what are the main steps we need to do on our side. So we set an SLA that we would like to have this calculation time under 90 milliseconds. So we have a warning threshold already at 80. We can have a serious if it goes over 90, and 100 is the catastrophic. So we already, this is very serious. We just, and you can also see here, you already saw in the core demo, the offloading process. So we can see that we have here catastrophic SLA violation, and we offload to the cloud another application to free some spaces for the thermal stability component. So using the thermal stability component has a high business impact. So we could use you can see here the influence on the thermal stability indicator. So this stabilizes here, and this can be already after 5 hours. We can already see that this is really stable. And usually a machine operator would go for 8 hours. So we could reduce to 5 hours. This means an increase in efficiency of 37.5%. So what are the benefits of using Pledger in this use case? So we can focus on creating business value, and we do not need to bother with all the manual deployment. Pledger chooses the best deployment option in the back. So also in case it needs an application needs to get offloaded, and so we can guarantee our quality of experience for our end users, Pledger chooses the best deployment option in the back, and we do not have to bother on where to go. We also have the easy monitoring of the infrastructure and the service performance, and we can improve the performance on the fly, as I already explained with, for example, with offloading. Now moving on to a further use case we have here in this pilot. So moving on to manufacturing of parts. So you can see here how it actually produces some parts and drills and mills to remove actual material. And yeah, this goes really fast. And this process has also some sub-processes. So there are, of course, some clamping and inserting and unloading involved. And we can analyze all these sub-processes afterwards, also to determine the process stability. So you can see here a short video on how a manufacturing expert would determine the process stability, and also sees anomalies and can get the reason for these deviations. So you can see here this part produced in a specific time frame, and you can also see that he can select the part and get some first overview of them. So he can now select 2 of the parts and compare them visually. What are the differences, and where are these differences? Was the quality okay? Where did we have some deviations in the machining process, or did the clamping just last longer? So you can find some root causes for deviations in the process stability. But of course, this has also quite some sensitive information in it, as it's crucial that all the parts are analyzed and the data is gathered also to determine this process stability. But the information about how many parts are produced and also the number of rejects or the number of good quality parts is sensitive. So this is something a customer doesn't want to give away, as this gives information about the running business. So in case the load is high, this means good business, of course. But what is the downside is when the load is not so good and they do not produce so much parts. So this is really critical and sensitive information. But however, we as a machine builder are interested in this information, for example, to establish also a business model based on pay-per-use. But customers do not want to share this information. So we had the opportunity in this project to evaluate which data can be stored on the edge and which can be transferred to the cloud. And we came to the conclusion that the evaluation of the data, especially which needs to be done for the process stability, is stored on the edge, as where also the front end and back end and all the accessing of the information is placed. So this data does not leave the edge. And to get this information about parts and how many parts to establish a business model, we used the Bledger DLT. So we can transfer the data to the Bledger DLT and store this in the cloud and give only authorized access to the information to specific people who need this information for billing processes, for example. So you can see here we have a very easy integration here with the stream handler already presented by Intrasoft, and the transaction is submitted to store the data on the ledger. You can see here just a quick snippet. And afterwards, an authorized user can access the Bledger wallet and retrieve the desired information. So the user can select a specific time range and get the amount of parts produced in this time range, and also the information about the quality of parts. And this is only for authorized users, and this is something customers accept. So afterwards, after the final pilot execution, we also evaluated the Bledger from both perspectives. So first from the developer's perspective, as we are software providers for our customers. And the second one was also from the end users, so for a manufacturing expert in the shop floor. So for us, the most useful features from the developer's perspective were the automatic deployment on the best infrastructure option. So all this, as already explained, all these processes is done in the back, and we do not have to bother with that. Also, the automatic offload in case the performance drops, and nobody has to select specifically again a new node. We just configure it once at the beginning, and then everything is done in the back. Also for test development and testing purposes, also to monitor the performance in a very easy way using this dashboards is very easy and valuable to improve the development process. Yeah, we also worked a lot of metrics and SLAs to improve the use case in terms of quality of experience, and it was quite crucial to point and pinpoint the metric to get this waiting time. So this was now the calculation time on how long it takes to determine this thermal stability indicator. And it enabled the developers to monitor and observe the performance of applications. And we will also continue this work in the post-project phase to improve the applications even more. Yeah, integration with Pledger was also very easy, as we have just two integration points to establish. So we have first the OpenVPN connection to establish connectivity. So this was how we did it. And so the components could access our applications and infrastructure. And the other way around is also using Stream Handler. So we have for example, for the monitoring engine, we pushed data to Stream Handler from where it could be transferred to the monitoring engine. We also integrated with the DLT using Stream Handler, and also with the data integration, as the application who gets offloaded to the cloud needs access to data to analyze it. So some media consumption data is not sensitive, so this can be also transferred to Stream Handler without any problems. And as soon as an application gets offloaded, it can just take the data from Stream Handler to do its job. Yeah, and yeah, this was yes, especially Stream Handler was an easy and well accepted solution, as yeah, publish and subscriber mechanisms are well established within our company, and developers are used to that, so this was no problem at all. Yeah, we are very happy with all the features developed within the project. Of course, we also had some opportunities where nice to have features in the future. One of them would be, for example, to have orchestration of infrastructures and services in a distributed architecture, which is especially crucial if you do not want to publish services on the internet, for example, and you would like to keep these endpoints private. But also, for example, a notification systems on specified SLA violations where pledger mechanisms are not sufficient to solve the problem and to improve the performance. So you can get a notification, for example, via mail, so you can handle this violation. And from the end user's perspective, we also have very good results. So we gathered and assessed the quality of experience during the pilot execution, especially whether interruptions during the warm-up process were experienced, and the users reported no specific interruptions. So this is very good news, and we are very happy to hear that. And the overall QE rating in the pilot was 4.57. So this is also out of 5. So this is very good. So it's 93%. And also the understandability of the user interface to determine the process stability was rated very good with 4.71 out of 5. And which is also quite interesting, we also asked internally in our sales department and also the project managers for customer projects, whether they see an increase in trust through the use of this DLT solution and just proposed, and with using Pledger Wallet and giving access to only authorized users to the sensitive information. And we experienced an increase in trust of 75%. So 3 out of 4 said, yeah, they can imagine this is an increase in trust for the customers. Yeah, that's already all from my side. Thank you for your attention, and I hope I could give you some insights into Pledger benefits for manufacturing. Thank you.
Thank you very much, Verena. I think it was very important to see how Pledger can be integrated in industrial environments, and in such a case, security and reliability are both a point of focus for Pledger. So I think that concludes our session on the Pledger use cases and the uses of the components and all the different subsystems in real-world cases. We have prepared an additional poll to gather your feedback on our specific use cases. Again, this is totally anonymous. It will take only 5 minutes for you to fill out the form, and we would appreciate to hear from you. So with that, I would like to pass the floor to our coordinator to wrap up the meeting and, of course, take all your questions regarding the use cases and the benefits of Pledger.
So before closing, it seems that there are no questions. So Olga, I think we can finish now.
Yes, and slightly ahead of schedule. So unless there are any questions, I suppose not. So we can wrap up and thank everyone for your attention during today's meeting and for the feedback that you have given us, both through our polls and through the chat box. And we hope that you found our presentations today to be highly informative and that you have gained some insight on the variety of benefits Pledger can bring to Cloud Edge deployments. Any additional comments from you, Lara?
No, just to say thank you to the presenters for the good job done, but also to the attendees because it was a really long morning. So I hope you enjoyed the presentations, and if you want to know more about Pledger results, you have all the links here and also in the shared video. And that's all from my side.
Okay, so thank you everyone and have a nice afternoon.
Thank you. Bye. Take care.
Thank you. Bye.
Thank you. Bye-bye.
Thank you.
Bye, everybody.
Thank you. Bye-bye.
Bye.
Thank you. Bye bye.